All right, today we are diving into the absolute fundamentals of metalworking, how you can take a raw piece of metal and shape it with nothing more than essential hand tools. This right here is where true precision is born. Let's get into it.
Have you ever really thought about it? How does a solid, simple block of metal get turned into a complex, precise part? It might seem like magic, but it all starts with one basic idea. You've got to take material away to create something new.
And that's what metal machining is all about. At its heart, it's a process of subtraction. You're not adding anything. You're just carefully, skillfully removing layers or chips of metal to uncover the final shape that you need.
Now, there are really two ways to go about this. You can use big, powerful, automated machines, things like lathes and mills, or you can do it by hand. And today, we're really going to focus on those foundational, hands-on skills that every single machinist needs to know.
So here's our game plan. We'll kick things off with the basic principles of shaping metal by hand. Then, we're going to decode the metal file, get into the science of sawing, and even the art of the chisel. And to wrap it all up, we'll talk about how you choose the perfect tool for whatever job you're facing.
So before you even think about picking up a tool, there are a couple of ground rules. Two things that are absolutely essential for you to succeed.
First off, and this is non-negotiable, your tool has to be harder than the metal you're working with. It sounds totally obvious, but it's a fundamental law of physics you just can't get around. And second, real precision begins way before you make the first cut. You have to mark everything out perfectly and think through your sequence of steps. You know the old saying, measure twice, cut once. It's gospel here.
Okay, let's jump into our first tool, the file. Now, it might look like just a simple, rough stick, but trust me, there is a surprising amount of engineering and variety packed into this thing. Let's just quickly break down its parts. You've got the handle, which fits onto a pointy bit called the tang. The long part is the body, which has the face, and the edge, that's where all the cutting teeth are, and it all ends down at the point. It's a beautifully simple and effective design. But here's the thing. If you go into any workshop, you're going to see tons of different files. So how do you choose the right one? Well, it all boils down to three key things: its shape, its grade, and its cut. Let's look at what each of those means.
Shape is pretty intuitive. It's all about matching the tool's geometry to your workpiece. Got a flat surface? You grab a flat file. Need to make a round hole bigger? You guessed it. You need a round file. Making a V-shaped groove? The triangular file is your friend. Every shape has a very specific purpose.
Next up is grade. And honestly, the best way to think about this is to compare it to sandpaper. A coarse grade, which they call a rough file, has these huge, widely spaced teeth for just ripping off a lot of material fast. Think of it like 80 grit sandpaper. Then you have a fine grade, a smooth file, with tiny, packed-in teeth for getting that perfect, precise finish, just like fine grit sandpaper.
And this picture just shows that difference perfectly, doesn't it? Over on the left, that's the rough file. You can practically see those big, aggressive teeth ready to just chew through metal. Then on the right, you've got the smooth file. The teeth are so much finer, designed for just barely skimming the surface to get that perfect dimension.
And finally, there's the cut. That file on the left is a single cut. It has one set of teeth all running parallel. It shaves metal away slowly and leaves a really smooth finish, which is great for hard metals or finishing work. But now look at the double cut file on the right. It's got two sets of teeth that crisscross. This makes it way more aggressive. It removes material much faster, but you're going to get a rougher finish. So it's always a trade-off. Are you going for speed, or are you going for smoothness?
Okay, so we've covered how to shape and smooth surfaces. But what about when you just need to cut a piece of metal in two? Well, that brings us to our second tool, the saw. And believe me, this isn't just about muscle. There's some real science to how a tiny saw blade can slice through solid metal.
Just look at this diagram. Every single one of those teeth on the blade is its own little cutting tool. It's got a rake angle designed to shear the metal, and the space between the teeth, the gullet, is designed to carry the little metal chips away. It's actually a little marvel of engineering, just repeated hundreds of times on one blade. To really get sawing, you gotta know three quick terms. First is pitch. That's just how many teeth there are per inch. You want more teeth for harder, thinner metals. Then there's set. That's the slight bend in the teeth alternating left and right, which makes the cut just a little bit wider than the blade so it doesn't jam up. And that cut itself, that's called the kerf. Pretty neat, huh?
All right, let's move on to our third tool, one that's all about applying controlled force. I'm talking about the chisel. This is how you chip and shear metal away to create different shapes.
The chisel is an incredibly simple tool in its design. You hit the head with a hammer, and all of that energy gets focused down into one single powerful line, the cutting edge.
And the real secret to making a chisel work is getting the angle of that edge just right.
And that cutting angle is so important. As you can see here, it has to be changed for different materials. For a really soft metal like aluminum, you want a very sharp, acute 30-degree angle. But if you're working on something tough, like tool steel, you need a much wider, stronger angle, around 65 or 70 degrees, so the edge doesn't just chip and break. It's another great example of tailoring the tool to the material.
And just like files, chisels come in all kinds of specialized shapes. The flat chisel is your everyday workhorse. A crosscut is great for narrow grooves. A round nose is for curved channels. And a diamond point is perfect for getting into and cleaning out those sharp square corners.
So after looking at the file, the saw, and the chisel, you're probably noticing a common theme running through all of this, right? It all comes back to that one guiding principle: choosing the right tool for the right job.
Let's just boil it down to the absolute basics. Each of these tools has a core job. You use a file when you need to smooth, shape, and finish a surface. You grab a saw when you need to separate parts or cut a section clean off. And you pick up a chisel when you need to chip away material to sculpt a new shape. Knowing what you need to do is the first step to knowing which tool to grab.
And this quote from our source material really just says it all, doesn't it? Whether you're doing it by hand or with a giant machine, the whole goal is precision. It's all about getting that part to the exact size and the exact shape it needs to be. And these humble hand tools, this is where that discipline truly begins.
And that kind of leaves us with one last big thought to chew on. We've seen the incredible precision and control that's possible with just these basic hand tools. It really makes you stop and think. If this is the foundation, what new worlds open up when you add the incredible speed, power, and automation of a machine? That's all for this explainer. Thanks for joining me.